I built a GPT-powered digital physical color translation system that converts hex codes sampled from images into the closest matching Ohuhu alcohol marker equivalents. The system references a custom-built dataset created from scanned marker swatches and uses a weighted perceptual matching algorithm to ensure accurate physical color selection. I created this tool in order to expedite how quickly I can create Ohuhu marker color palettes that I sell as digital downloads on my Etsy shop. I know that was a lot of words there, but let's go ahead and explain that a little further. Essentially, I sell digital files on Etsy. I have a shop on Etsy that sells quite a few different things. Here's a little glimpse into my shop. But one of the best sellers on my shop are color palettes. I've created these using different source images. For example, here's one color palette that I created. And what is special about these particular color palettes is they're matched to these markers called Ohuhu alcohol color markers. The concept of a color palette is not new by any stretch of the imagination, but how these stand out is rather than just telling someone that they're going to use an orange because it's inspired by that particular photo, that person still has to make another logical leap and decide which shade of orange from their set of particular medium color pencils or markers or crayons. They have to manually color match that orange still. And I thought it would be neat if rather than just telling you need some kind of orange, to tell you specifically what kind of orange. These markers are fairly popular on Instagram and TikTok. They have a little bit of a cult following, if you will. So I figured they would be a good target market to start with to see how well they would sell. This is a 320 set of markers, and each marker has its own code. As you can see, mustard is Y111. So in order to make these palettes, you can imagine that it's pretty time consuming to do, because I go through and make quite a few of them. Here's another example. And there's one page of one of the files that I would sell. So in order to make this faster, I first set up a database with the markers. So here's my database that I actually use to feed into the GPT. Each one has a color name. It has a new number code, just like on the cap of the marker. It also has an old number because Ohuhu switched their numbers about July of last year. So each marker has to have two separate codes attached to it. I also took physical swatch samples and converted them into digital HEX codes. That way I would be able to tell the GPT what the actual color looks like. And then I took that HEX code and I converted it into RGB, hue group, saturation, and brightness. The reason that I had to break it down so much into more specific data is because when I first started trying to get ChatGPT to do this, I was finding that it would pull dull or neutral colors, which were not wrong colors because photographs, and especially in nature, actually have a lot of neutrals. But what I was finding is that those were kind of boring colors to pull. I didn't want someone to be inspired by a color palette and then have them just look at the same color gray. So I wanted it to pull more of a vibrant color and go more with an overall perceptual match, essentially the main colors of the photograph. So I had to teach the bot, if you will, how to find that. So I created something called the weighted hue saturation color match method, which I actually built into the GPT, so it knew which colors I wanted it to sample from. So let's go ahead and show you how this works. Let's pull up ChatGPT again. In order to do that, I have Unsplash pulled up. I'm not really downloading the images right now, but they are free to use. So I have a color sample already of this sky here. It's a teal color. I have that sampled up here. So we're going to copy that hex code. So it's 74B. Let's make sure we put the right one in. I have the GPT set up so it only accepts hex codes as input. It's a singular machine, essentially. So if you try to put anything else into the GPT, it's going to reject it and tell you that it can't perform that task. All I want this GPT to do is take the hex code, input it, and then I want it to output. It's going to give me 1 to 3 of the closest color matches that it could find using that database. So we're going to go ahead and submit this hex code. Now Now, behind the scenes right now, not only is it following the instructions, it's listening to the different guardrails that I have set up. It's particularly making sure it does not make up or hallucinate any kind of markers from the web or its own imagination. It's only going to use the data set that I have provided it. And it's also going to use that weighted hue saturation color match method, so we won't get any sort of gray colors or black colors or really kind of boring neutral colors. It should pull pretty close to that particular teal color. Okay, let's go ahead and test it. Let's see, R015, was that the right hex code? No, it was not the right hex code, so I knew that because the R numbers are normally red, so we're going to run another hex code here. I don't know why my copy and paste function was not working, but let's try this again. Okay, so this should give us a teal color, not more of a red color that it was pulling. Oh, see, and it rejected my hex code because it wasn't set up in the hex code format, so that's actually a good thing. That means the GPT is functioning as I set it up, because it wouldn't take it as a valid hex code. Let's try this. Okay, there we go. Let's first make sure that these particular markers exist in my data set, because I want to prove that the GPT didn't hallucinate or actually make up these numbers and they pulled it right from the data set. So let's try BG09. If we scroll down here, we have BG09 and then the matching G326. So that's good news. That worked. And then we have BG114, and then that one matches to PB9. So we're good there. And then we have BG05, and that matches BG68. Okay, so it did not hallucinate or make up any markers. It only pulled markers that I actually own. So that's a good indicator that we're working. And now we're going to go through and make sure that the colors actually match. Remember, it was a teal color. That's almost a perfect match right there. So that would be the best match. I believe, but these should be pretty close matches as well. Oh, that one, who knows, that might even be better. Remember, this color up here in the sample is the color that we were trying to get it to match, which so far so good. It's doing a great job. BG5 there, and then that's just a little bit lighter shade of that. So those are three really solid options to match that color sky. So someone could then use that as an inspiration color, and then they would know that they could pull one of these three particular markers that they would be able to find in this set. Let's try it one more time just so you can see that it's not a fluke and it does consistently work. So we're going to pull a different color this time. Let's go with a green color. Go with a brighter green, a little bit brighter. Okay, I'm going to make sure I type in the right hex code this time. Okay, oh, why is it not? There we go. So it should be 7CB. Okay, 7CB0. And this color green up here is the green that we're trying to match. There we go. Okay, let's again make sure that it did not hallucinate these markers and that they actually exist in my data set. And this one does. YG211 matches with G15, so that one is good. We've got YR111. That one matches with Y10. Good. And then we've got YG610. And that matches with G170. Okay, so success. We have 3 markers that actually exist in the database, so it followed the guardrails exactly as I have them set up. And now let's check the colors. Remember this green right here, kind of almost like a Granny Smith or apple green, what we're trying to match. Okay, good. That right there is a great match. So number 1 is success. That one's not a great win, but that's okay. Let's see how there we go. So 2 really solid matches. The third one is a little bit of an outlier. I'm sure it did something within the algorithm that made sense that it actually would match, but in that one it did whiff on a little bit though. All right, let's do one more just to see how it goes. This will be the last one. Let's do this yellow. And we've got, oopsie, why is it not copying it right? F2C54D. Okay, I can tell already these are going to be good because they're all Y's, so those should all at least be in the yellow family. But let's go through the steps here. Okay, we're going to make sure first that it did not hallucinate or make up any of these markers. Number 1 is good. Y27 matches with Y1, so that one is in there. And then we have Y26 matches with Y3. Okay, so that one is in there. Now let's check the colors, see how it did. So Y19 is our first color, and remember we're trying to match this particular up here, this color, this yellow. So Y19 would be right here. Oh, that's a good match. This canary is what it's matching. Then we've got Y27. Ooh, I like sunflower. That's a really good match. That one's near perfect match. Y27 and then Y26. And then there we go. So that was 3 successes. So it did whiff a little bit on the orange there, and sometimes that does happen. That's partly why I have it set up to do 1 to 3 matches. That way you are more than likely to get something that matches pretty successfully without having to keep rerunning it. It just gives you 3 of the closest possible matches all at once, and then I don't have to keep continually rerun the process if it does whiff like that. But I would say that's a fairly good success. So if you have any questions, just let me know in the comments. I appreciate you watching.